Hello student, welcome back to lecture series on numerical methods. We have started unit number 6, which is the interpolation, numerical differentiation and integration. Okay, so within that I already explained to you all Newton's forward interpolation formula, forward difference. Okay, so in my today's video guys, I'm gonna explain to you all the backward difference, okay, like as I did in my previous lecture for the forward difference. Okay, so without further ado, let's get dive into our today's lecture. First of all, we're gonna see what actually the backward difference is, and then we go for solving some of the example. Okay, now see that forward difference. Okay, forward difference denoted by delta. Okay, forward difference denoted by delta. This one is our forward difference. Let me explain some of the concept for forward difference. Okay, this one is a delta of f of x. We are writing delta of f of x as a forward. I'm writing here for the forward difference guys. Okay, so what actually forward difference here? Delta of f of x is equal to f of x plus h minus f of x. Okay, this one is our forward difference. Okay, so using this forward difference we are going for the backward difference. Okay, this one is for forward. Okay, we go for the backward now. Backward. Okay, so backward difference denoted by del. Okay, this one is a 180 rotated delta. Okay, so we consider it as the del, del. This one is our mathematical symbol del, which denoted as the backward difference. Okay, backward or ascending difference. Okay, so if you want you can take here ascending difference. This one generally we called as the backward difference. Okay, backward difference or ascending difference denoted as a del. Okay, and written as del of f of x. Okay, designated as a del of f of x and written as, so now see that we have some of the arrangement here. Okay, that f of x, make that negative f of x to the positive f of x. Okay, take this negative f of x to the positive f of x. Okay, and after this what we do, so I take this negative to the positive f of x, and that positive f of x plus h take it to the negative, so negative of f of x minus h. Okay, make sure that this one need to understand. Okay, so this is a very easy trick to remember forward difference and backward difference. Okay, so forward difference denoted by delta and backward difference denoted by del. Okay, so del f of x is a f of x minus f of x minus h. Okay, so we are going to generate our second backward difference, third backward difference and nth backward difference. Okay, like as we did in our forward difference. Okay, yes. So in particular already I explained, so I'm not going to put this value and further iterations. Okay, so I'm going to write directly the value delta of y1. So if you want detailed understanding you can check my first video. Okay, so I explained everything there. Y1 minus y0, delta of y1 means y1 minus y0. I explained this one in a Newton forward interpolation example. Okay, so you can check it from there also. Delta of y2, oh sorry, del of y2, del of y2 means y2 minus y1. Okay, up to the del of yn. Okay, so how can we write del of yn? Del of yn, which is a yn minus yn minus 1. Okay, yn minus 1. Okay, so this one is the from our first forward difference. Okay, let's go for the second forward difference. Okay, second forward difference. Okay, second forward difference means del square. Okay, del square of f of x. So we know that del of f of x, so expand this del as a del into del f of x. Okay, so del f of x, we know that f of x minus h. Replace this value here, f of x minus f of x minus h. Okay, this one is a del of f of x, which is a backward difference. Okay, apply del to the inside bracket, del f of x minus del f of x minus h. Okay, that what I have done, I taken this del under bracket over here. Okay, yes. Now what we do, so apply the del f of x value for del f of x minus f of x minus h. Okay, so f of x minus h. Okay, minus times f of x minus h, replace x as a x minus h. Okay, so f of x minus h minus f of x minus h minus h, x minus 2h. Okay, so we write f of x minus h. Okay, so f of x minus h here. So f of x minus h we want here. Okay, so f of x replaced by x minus h. Okay, so we write f of x minus h. Okay, f minus of f of x minus h, and then f of del of f of x minus h means f of x minus h minus h. That means f of minus of f of x minus 2h. Okay, x minus 2h. So f of x minus h, a minus of f of x minus h, take it once. So f of x minus 2 times f of x minus h minus f of x minus 2h. Okay, this one is a del square of f of x. Del square of f of x, this one is. Okay, yes. So you can go for the del cube of f of x, del raised to 4 of f of x, and so on. Okay, so you can see in my corner of the screen you will get the backward difference table. Okay, so how can we define the backward difference? Okay, so it is similar like a forward difference, guys, not that difficult. Okay, just need to replace the negative as a positive. Okay, not that difficult. I'll tell you all the trick how to remember these formulas. Okay, yes. So see that del square of f of x I written here. Okay, so let me take to the take this one to the value of y2. Okay, so f of x consider is y2, del square of y2, which is equal to, so f of x, it gives us the value y2. Okay, y2 minus 2 as it is f of x minus h, we are taking h out from there. Okay, so we write it as the y1. Okay, if 1h taken out, then we write y1, 2h taken out, then we write y2 minus y2. Okay, this one is minus y2 only. Okay, so I hope you all have understood this one is y0. Okay, if 1h taken out, we write y1. Okay, so see that if single x is there, then y2. If 1h taken out, y1. If 2h taken out, obviously y0. Okay, yes. So you can write delta cube of y3. Okay, so how can we write delta cube of y3 using this one? Generalize the result. Y2 can be replaced as, when 2 is there, 2 is there, so y3 minus 2 as it is. Okay, and when 2 is there, we write y1. So when y3 is there, we write y2, and when y2 is there, we write y0. Okay, and when y3 is there, we write y1. Okay, see that how easy it is. So if you want, you can generate delta cube of yn. Okay, we can write delta cube of yn is equal to yn minus 2 times yn minus 1 minus yn minus 2. Okay, so this one is a plus. Okay, might be this one is minus of f of x minus h. Okay, so this one might be, this one is the plus term, guys. Okay, so this one is a plus. By mistake only minus it gives us the plus. We made mistake here. Okay, so this one is a f of x plus f of x minus 2h. Okay, this one is the plus value. Okay, so if this one is plus, this one is plus, then this one goes to plus, this one and this one also plus. Okay, so make sure that about these values. Okay, need to be careful while calculating. So we forgotten the negative sign here, so negative gives us the positive. Okay, so just extend these results, you will get the nth forward difference as a delta cube of yn. Okay, so you can see here in my corner, so you can see here in the corner, you will get the table. Okay, first argument as x. Okay, first argument as x, then after that entry as f of x, first forward difference, second forward difference, third forward difference. Okay, so you can find out the nth forward difference like this. Okay, it's very easy to find out, guys. Okay, I hope you all have understood. This is the explanation, this is the complete detailed understanding of a backward difference. So there we have some of the properties. Okay, if c is a constant, then forward difference of a c is a 0. Okay, if a forward difference of f of x into g of x is there, then we write f of x plus h into forward difference of g of x plus g of x into forward difference of f of x. Okay, there are 3 to 4 properties that we will take it here, guys. Okay, 3 properties are remaining, then we'll go for some of the example after this. Okay, yes, properties of the forward difference. So see guys, here I added some of the properties. Okay, so first property, it says that if c is a constant, okay, if c is a constant, then forward difference of that constant term, okay, which is 0. That means if you want the forward difference for 10 or any constant term, it always 0. Okay, so forward difference for any constant term is a 0. Okay, so we want the next forward difference of f of x into g of x. Okay, so multiplication of two forward difference is a f of x plus h into forward difference of g of x. Okay, so f of x write as a f of x plus h, then forward difference of g of x here plus g of x as it is forward difference of f of x here. Okay, yes, my third property, it says that forward difference of f of x 0. Okay, it doesn't mean that delta 0. Okay, that delta 0 or f of x 0. Actually, it is doesn't mean, if forward difference of f of x 0 means, does not mean that delta 0 or f of x 0. Okay, so as we know that forward difference of f of x into g of x, we go for the forward difference of f of x upon g of x then. Okay, so guys, see here I added one forward difference of f of x upon g of x is a g of x into forward difference of f of x minus f of x into forward difference of g of x upon g of x plus h into g of x. Okay, like a derivative of u upon phi into derivative of u minus u into derivative of v upon phi square, but instead of phi square we have g of x plus h into g of x. Okay, so just to remember this formula, you can take the feelings from the differentiation of a quotient rule. Okay, so you can remember this one for forward difference of f of x upon g of x. Okay, so I hope you all have understood, guys, here my today's lecture based on the forward difference. Okay, which means ascending difference. Okay, so which denoted as a del. I written here some of the observations and their properties over here. Okay, yes, I hope you all have understood, guys, everything here in my today's lecture. That's it for my today's lecture. Okay, if you have anything doubt, difficulty, let me know, guys, in my comment section. Okay, so thank you everyone, thank you for my today's lecture.